Hello, this is Vignesh Gopal, and I am doing my marking period for Screencast. This will be a review practice problem for pulleys, which I understand a lot of people still are unsure about. So here's a practice problem for pulleys. It may seem complex at first, but it's really not so bad. So you have four main components: the 4 kilogram block, the 2 kilogram block, the 10 kilogram block, and the 8 kilogram block. The 10 kilogram block isn't that important. It'll only be used in the acceleration, which I'll get to later. So here are the forces that we need to find. So the 4 kilogram block would be mg sine theta, as seen over here, if you draw a force diagram and such. Then the 2 kilogram block would just be mg, because it's basically on a free fall, or Earth is only pushing in this way. And the 10 kilogram block, as I said before, doesn't have any forces acting upon it because there's no friction. Then the 8 kilogram block would also be mg sine theta. Now here are the directions of the forces. So the 4 kilogram block, as seen in the picture, would be going this way. The 2 kilogram block would be pushing downwards, which would be going the opposite way. And as with the 8 kilogram block, and as I said before, there is no force on the 10 kilogram block, so it would be going wherever the acceleration is. And yep, that's what it looks like over here too. So here's the equation for the sum of forces. So you have mg sine theta plus mg. So the mg mass is the 8 kilogram block, and the theta is the angle on the ramp which that block is on, plus mg, which m would be the 2 kilograms from that block, minus 4 kilograms times g times sine theta, which would be the 4 kilogram block and the angle of the ramp that that block is on, which should equal the sum of forces, and that does not equal 0 because the whole system is accelerating. So here's the full equations with all the values. So acceleration equals sum of forces over mass, as we know. And since it's in a pulley system, you have to include all of the masses. So the 4 kilogram block, the 2 kilogram block, the 10 kilogram block, which didn't have any forces acting upon it, but now we have to include it in our system because it is in our system, plus the 8 kilogram block. So I just plugged in my values, 8 times 9.8, as seen over here, plus 2 times 9.8, minus 4 times 9.8 times sine 45. So when you solve for all your values, your acceleration should round off to 1.6 meters per second squared. And when we check that with the answer key, we find that we are correct. So that is how you solve for pulleys. If there's any problems, what I would suggest is just draw the force diagrams, and you should be good from there. Thank you for listening.